Good afternoon. Really excited to talk with you today. I'm going to go over the 3 things you need to know before getting ready for a great crowdfunding campaign. And I've put the link up here. I don't know if anybody takes notes, but if you were going to, you can avoid that and click here. So before I get rolling, I thought it might be useful to do a quick survey just to see who's out there. So by a show of hands, who has built a working prototype before? Cool, not too surprising. Has anybody built and sold more than, let's say, 5,000 units? Okay, a few. Can we get 50,000? All right, gentleman in the back. Awesome. Cool. Well, it's an amazing rush. I spent a long time at iRobot before starting Dragon, and I know one of the biggest thrills was walking into a store and looking at the shelf and seeing somebody come up to a Roomba and sort of play with it and look at it and pick up the box and then hopefully eventually buy it. But either way, just like seeing people interact with stuff that you created and know the whole story of where it started with the napkin sketch and then the prototype and then picking a factory and scaling up through manufacturing is just a really fun, it's just a really fun experience. So I hope you all have the chance to enjoy that. At Dragon and at Bolt, we spend a lot of time thinking about manufacturing. And the challenge here is that it's insanely complex. We like to joke that there's a lot of unknown unknowns. Like, it's definitely possible to learn this stuff. I spent 10 years at iRobot building the first 4 million Roombas, and of that, 4 of those years over in China, very much hands-on on the line and watching the robots roll off. And it's definitely a skill you can learn. The challenge is it takes 10 years. And a lot of new companies, whether they're crowdfunded or venture-backed or bootstrapped, are going to have to go and build it, ideally in volume. And if you don't understand the process, and it's unfortunately something you just can't Google manufacturing and get the answer you want, a lot of really bad things can happen. So, just looking at why is this stuff so hard? Well, software is a key part to have on hardware. We sort of think of hardware and software together. But if you look at the hardware part of it, there's a lot of differences between software and hardware. One is we have these COGS, which are cost of goods sold. So you actually have to buy physical ingredients, atoms, and put them together. There's also different costs associated with the tools, the big chunks of steel that Aaron was talking about that are going to eventually go ahead and make your sorted clamshell cases and structure. Things have lead times, so you can't just hit the button and instantly compile. But often for the bigger components like your processors and radios, you might be looking at something on the order of 12 weeks for a lead time. And if your schedule is, or your revenue is really driven by hitting the holiday season, so hitting the Christmas season, and you haven't planned on this 12-week lead time, that can totally destroy your ability to get revenue for that year. So it's really important to know that stuff. Quality is permanent. So in our world, we sort of look at what can go wrong in 3 things. There's critical, there's major, and there's minor. Critical means if you get it wrong, you kill somebody, and that's obviously an incredibly bad outcome. Major is the person gets the product and it just doesn't work, which is definitely less bad, but not what you're looking for. And the minor means it doesn't work. But the challenge is, as you ramp up your manufacturing, say at Roomba, and I'll show you a picture of the factory a little bit later, we used to build about 40,000 robots a week, and it took about 10 weeks from when they left my dock until when they got into a customer's hands. So if you do the math, like that is a lot of robots, and each robot's about $100. That's really $4 million you have floating around, that if you screwed up the quality and don't find out for 10 weeks, you've just bled the company dry. And that would be the best of possible outcomes. Hopefully you haven't hurt anybody from a more serious quality problem. So quality is really important. You can't just send over the error updates for your firmware. It takes a while to iterate, be it tooling or prototyping or 3D printing. It's not an instant process. You need this really cool thing called DFM, or Design for Manufacture and Assembly. So if you look at just a prototype, it's probably either 3D printed, where you can violate the rules of nature and build these cool things that you could never even imagine before. Or maybe it's a CNC housing, but it's probably not designed for injection molding with 2mm walls, half a degree of draft, rounds, and so on. So you have to be able to understand that and add that in. And then you have to bring in a lot more people. So you need a great factory who's going to be a partner to build the product. You need people with different skills from electrical, software, mechanical, maybe firmware, costing and sourcing, and so on. So it's the ultimate team sport. but it does require a lot of people. And then you need project management to stay on top of the schedule. So that's why this stuff is hard, but also why it's so much fun. Hardware also requires cash in that you have to buy tools and inventory and things like that. Eric did an awesome job talking about the different ways to raise money and the different business options. So I'm not gonna dwell on this, but typically hardware will require more money than software, and it's enough that most people can't write the check out of their pocket. So what I really want to focus on today is getting ready for crowdfunding. And after me, Kate's going to do a great job of telling you how to run an awesome campaign on Indiegogo. The trick is, before you start the campaign, to succeed as a company, it's absolutely important that you don't sell something you can't build. So crowdfunding is an incredibly powerful tool in our arsenal, in that, unlike the old days, and I'll use the example again of iRobot, where initially what we did is we ended up building the Roomba, and we had no clue what the hell we were doing, but we figured it out. We spent about $10 million in 3 years of our lives building this robot, and when we did it, for the first 2 years, I literally couldn't build them fast enough. Like, the demand was infinite. The biggest problem was, how do we get more output out of the factory? And we assumed, being good engineers, like, oh, everything we do is just gonna follow that path. How hard can it be? So we ended up building this product called Scuba, which is a really elegant floor washing and vacuuming robot. And we did the same thing. 3 years of our lives, $10 million, built it. And the problem is, nobody bought the thing. And I just remember, oh, we sold one. That's awesome. Eventually, we did get the formula right. But we ended up coming out at a $400 price point. And the thing we didn't realize, or we knew but we didn't connect the dots, is that a mop and bucket costs $10. So why would you buy a $400 robot that you still have to put the stuff in and get the dirty water out of versus a mop and bucket? Now, the customers knew that, and they voted loudly, but that ship had sailed a little bit. And it was just incredibly painful having bled for this product, and just such a different outcome from Roomba. So what I love about crowdfunding is that you can get that product market fit early before you go through all this time and effort. And you could also do focus groups, but I'm not a huge fan of those, because if people don't vote with their wallet, it's not as true of a signal. You create an engaged community, which Eric also talked about, super efficient form of marketing and setting up virality. And you also get the cash, which you need. So crowdfunding is incredibly powerful. But if you do sell something you can't build, it's going to be a very slow, painful public death, in that your strongest supporters are going to be your backers when they bought into the promise of what you're doing. But after it's been a year, 2 years, and you haven't delivered, it typically turns ugly. And I want to help you prevent getting in that situation. So there's basically 3 questions from a manufacturing side that you have to know before you crowdfund a hardware product. How much money do you need? So what's your threshold? How long is it going to take before you can deliver? And from where you are now, how far away are you from a design that can be handed over to the factory to start production? And what I'll do in the next few minutes is just break down at a high level these 3 different questions so you can have a framework for how to think about them. So how much money do you need? And this is really important because it's going to dictate your funding threshold. Now, if you have external funding, that's awesome and amazing, and you can certainly adjust your threshold accordingly. But what we see in our business at Dragon, where we work with a lot of hardware startups to help them get ready for great crowdfunding and then move into high volume production, is that often, or at least let's hope it was in the older days, people would pick a threshold out of the air because they thought they could exceed it. So, $50,000, that seems like a pretty good number. I can probably get over that. And it's low enough that if I set up stretch goals, maybe I can get to 200 or 300 and say I exceeded it 4 or 5 times, and that's awesome. The problem is, if your tools cost $70,000 and you only raise $50,000, you're porked because you just don't have enough money to even buy the tooling, much less the inventory. So it's incredibly critical to figure out actually how much money you do need. And if you want to augment it with your own money afterwards, that's great, but know the number. So if we look at, why do you need money? Well, it's to cover a few things. One is any non-recurring engineering, or NRE, to get from your prototype to the design for manufacture stage, where you can hand it over to a factory. You have to cover the inventory of your product, which we call the cost of goods sold. So how much does it cost to buy from the factory the thing that you're going to sell? One that's often forgotten is the tools. So you have to buy these big steel molds that Aaron just showed you, and they can cost a significant amount of money. For the first Roomba, we had about $200,000 in tools. For subsequent ones with multiple up, multiple cavity, it was more like $1 million of tools. So most crowdfunding campaigns will be much lower than that, but it's real money. You have to pay the factory, and if you're working with somebody to help you manufacture, that costs something. And then also all of the platforms will have a transaction cost as well they should, and you want to factor that in. What I'm going to do here, just because we're on limited time, is focus on the cost of goods sold. And the whole trick with this is getting transparency. What we'll typically do is work off the bill of materials, which is just, in the most basic sense, an Excel spreadsheet itemizing the different ingredients that go into making your product. And we'll want to figure out, line by line, what does every component cost? And in many cases, we'll want to break it down even further. So if we look at this clicker, it's a conventional clamshell housing. Rather than knowing that the back of the housing costs 28 cents, that's not that useful to me. What I want to do instead is know how many grams of Chimay 747 ABS plastic is it, what percent regrind, how many cavity, how many up, what's the weight of the runner and the sprue, and what's the cost of the plastic in dollars per kilogram. Then it's just math. And I already know what the cost of the plastic is because I can look that up on a site, or at Dragon we just know that. So I can make sure I'm getting a fair price. On the second side, you've got to pay for the overhead of running the machine. So what size tonnage machine it is, how long is the cycle time, and what are you paying the workers to build it? And based on those inputs, I can actually calculate precisely what this should cost. The whole trick with bills of materials is avoiding mystery meat. You always want to be careful if a factory just gives you a lump sum for your product. So if they were to tell me the cost of goods of this Q clicker is $5, that's absolutely useless to me because I just don't have transparency. It's also an incredible engineering tool in that most likely this is made out of ABS. If for some reason I was afraid it would get dropped, then I'd probably want to make it out of polycarbonate. But I'm curious, what's the cost difference going from ABS to PC? If I just knew it was $5, there's no way I can figure that out. But the way I've described it, all I would do is change the price of ABS in dollars per kilogram to the price of PC. It's all mathematically driven, and the answer squirts out the bottom. So it's a really powerful engineering tool that you don't need to go back and forth with the factory. Other key things that we find a lot of folks forget is labor. So you have to pay the workers to put together the product. And it doesn't matter if you build in Mexico, the US, China, or someplace else. There's always a labor rate. And that does vary greatly. And then not everyone is perfect. So there's some scrap rate. As you get your design more mature, I'd expect this to be about 0.5%. When you start off, maybe it's 5%. We've seen some that are as high as 50%. So 1 and 2 doesn't work. Obviously, that's not sustainable. You want to drive it much lower. But you do need to account for that in your business model. And then you have to pay the factory both their profit, because they won't work for free, and also the overhead of running their company. And again, the whole trick is just transparency down to the atomic level. So that's how much do I have to raise. How long is it going to take to get this thing done? Well, here I'll use the analogy of an alphabet where A is the idea, and then Z is the product delivered in the customer's hands. This is often the perception we see. So coming up with an idea is pretty hard. That's going to take a couple letters. Then we prototype this thing. We got one working. All right, we've got one working, and we're pretty much good to go. We do the crowdfunding campaign, we manufacture it, and we ship it. What is more realistic in our experience is a few letters, A and B for the idea. Prototype should be able to be done pretty quickly. It's essential, based on what we're talking about today, to get ready for a crowdfunding campaign as opposed to just run one because you can. You want to think through this stuff very carefully, especially if you're building a company, because you've got one shot if you crowdfund to get it right. You'll run your campaign. Kate will know the stats better than I do, but typically about 30 days is the right length. Then you'll manufacture it, and there's a big chunk, as you can see, going from one to many. With one, you can touch every little piece of the component. You can tweak and tune it so it works perfectly. When you're building, say, 40,000 a week, there's no way you could even talk to all the workers working on the thing, much less interact or actually touch the product. So it's a whole different order. It's a whole order of magnitude more complex. And then it takes a while to deliver it. So what I thought might be useful is just to take a look at the Roomba line. This is me back in '05 with a video camera before we really had phones running down the line. And keep in mind, this is just one of 4 branches that we're building the product. We had about 5,000 workers. This is only about 1,250. So if you think about the idea of say 7 people design the product and then somehow getting all that knowledge into these 5,000 people so they can build a quality product that stays out and doesn't come back and doesn't hurt anybody, it's somewhat of a challenge. So you want to really be very cognizant of that as you start moving into high volume stuff. In terms of the schedule, as we talked about, a lot of this is driven by the holiday season, or at least consumer electronics, which is the area that I focus in. And unfortunately, Christmas has a definite date that doesn't slide, and that can create a lot of problems. One of the first products we built with Hasbro was this thing called My Real Baby, and it was a pretty cool artificially intelligent, expressive baby doll. And it was our first time doing this. We thought we were going to ship in September, which is critical so you can start laying down the ads and get the doll on the kids' Christmas list. We actually didn't ship until November. And we built and sold about 100,000 of them, which is barely getting to first base. It's a product that, at least only for me at least, I'm convinced we could have sold millions. But we got there late. We were with Hasbro. Mattel had a similar product that wasn't as full featured, but they weren't late, and they laid down the marketing, and I think they did sell millions. So it's absolutely important for consumer electronics that you're not late. Things never go according to plan. You want to plan in contingency. If something's slipping, remember, hope is not a strategy. You've got to figure out that it's slipping and take immediate action to get it back on track. And things, again, never go as planned. In terms of how long it takes, rough rule of thumb is to get ready for a crowdfunding campaign is about a month minimum, ideally 2 months. To run the campaign we talked about is 30 days. Then you have to pick a factory. That's 1.5 to 2 months. And then from having picked the factory until the first product rolls off the line is about 9 months. And then depending how you ship, air or sea, it could be anywhere from 2 weeks to 6 weeks after that. So about 13 months is from picking the factory, or from starting to pick the factory until the product's in the customer's hands is our experience. I'm going to move along quickly because we're almost out of time. These are just the different steps that I just described. And again, feel free to take a look at the notes. And then finally, for the status of your product, it's everything from a sketch on a napkin to the chicken wire and duct tape to 3D printed parts. And again, don't fool yourself that you can manufacture a 3D printed part because you've probably violated all sorts of laws of nature. That has to be made into a prototype and then, or into machined and then designed for manufacture and assembly. Then you actually release the parts for tooling, and then you get the final product. And that's what we got. Thank you.